Welcome everyone. So our project focuses on context-free grammar transformations, a fundamental concept in theory of computation that plays a critical role in language processing and compiler design. So our problem statement is CFGs can become complex with redundant rules like null productions, unit productions, or useless symbols. These complicate parsing and increase computational overhead. So our project aimed to simplify CFGs while preserving their language equivalence. For this, we have used the PyCFG library available in Python for implementing grammar transformations. It provided a robust framework for parsing and modifying grammars. CFGs can become complex with redundant rules like null productions, unit productions, or useless symbols. These complicate parsing and increase computational overhead. Our project aimed to simplify CFGs while preserving their language equivalence. Chomsky normal form, the grammar was transformed into CNF, where rules are standardized for efficient parsing. This form is crucial for algorithms like CYK parsing used in compilers. Removing null productions. Null productions which generate an empty string were eliminated by rewriting rules while preserving equivalence. Here you can see the examples. Removing unit productions. Unit productions like A implies B were replaced with the rules of B to simplify the grammar. Here you can see the examples. Eliminating useless symbols. Symbols that do not contribute to string generation or are unreachable were removed. Here you can see the examples. Here in this example, the C is not defined in the main string, so C is useless as it cannot be reached from S or generated. In this code, we have used the Python library PyCFG and we have used the tkinter, where tkinter is a Python library that allows users to create graphical user interfaces. And now next we'll proceed on with how to run the code and see the solutions. Now we'll proceed on with giving the inputs and getting the output for the following. Firstly, the context-free grammar, shortly called as CFG. It is a formal grammar used to define the syntax of programming languages and structured data. And the components of CFG are non-terminals, terminal, start symbol, and production rules. Here we are giving the example, you can see, and at the down we have to specify what are the variables, start variables, terminals, and null characters. And when we give as a evaluate, it will tell us whether it is a valid string or not. Now it is a valid, so it showed as a valid. Now we'll check for another string where it is so it is invalid string. Now next we'll move on to Chomsky normal form, shortly called as CNF. It is a standardized form of CFG where every production rule is one of the following, where one non-terminal tends to two non-terminals on the right side and one non-terminal tends to a single terminal on the right hand side. So now we can see the example and now we can check for it. So here we can see it is being converted into the Chomsky normal form. Next is removing the null productions. Null production, a rule like A tends to epsilon, where epsilon refers to an empty string. The problem is that it can lead to ambiguous derivations. The solution is that identify nullable variables, replace rules that depend on nullable variables by including alternatives without them. Here you can see the example. S tends to A, S, A, where A tends to null. Now it will be removed. Yes, now we can see that it is being removed. Now next we'll check for removing the unit rules. Unit production rule says that a rule where a non-terminal maps directly to another. The problem is adds unnecessary steps during parsing, which leads to inefficiency. The solution is replace unit productions with the rules of the non-terminal they point to. Example can be seen on the screen and it has been removed. the unnecessary steps. Next, we'll move on to removing the useless symbols. We have two types of useless symbols. One is non-generating symbols that cannot derive any terminal strings. The second is unreachable symbols, never appear in derivation starting from yes. The solution is identify and remove these symbols to optimize the grammar. Here we can see the example on the screen, and we are giving the variables. Variables is the non-terminals that we have to specify, and then the terminals, and then evaluate, and then now we can see the useless symbols has been removed, and C is useless as it cannot be reached from yes or generate string. And here is output. Thank you.